Let's get started with our today's event, which is beginner overview of data structures and algorithms. Firstly, thank you for joining this meeting today with us. Before we get started with today's event, I'd like to introduce a bit about Women Who Code as an organization. So Women Who Code has a main vision. Women Who Code's mission is to empower diverse women to excel in technology careers. It's based out of my personal experience that I've been working as a volunteer with Women Who Code, and it's been an amazing experience till now. And luckily, I got an opportunity to lead this community, and I'm one of the leads with Women Who Code Cloud Track. And I would encourage everybody to join us. And it's a very good opportunity for global women and anybody who is supportive in technology careers. You're always welcome to join us. So that it's the mission of us, and the main vision of Women Who Code is we are a diverse woman, and we are historically excluded people who thrive at different levels in their technology careers. We also have code of conduct. So code of conduct is something which every organization has, and Women Who Code as an organization is an inclusive community. And as I said before, its main mission is to empower other women to grow in their technology careers. And we have applicable code of conduct to all our events and online communities. So you can visit our website, which is womenwhocode.com/code of conduct, if there are any incidents happening with you from our community. So we also have our events page, which is womenwhocode.com/cloud/events, wherein you can get all the details about the upcoming and past events. And good thing about our events are they get recorded, and even the present event is getting recorded. And once the recording is done, it's going to be posted in the YouTube channel of us. So even if somebody misses to watch it or be present during the event, you can always you can always request for the recording, and we would be happy to help anytime with regards to your career or professional or personal level. So that's all about Women Who Code organization. And we can always stay connected on social media platforms like LinkedIn, Twitter, and Instagram. And once this event gets started, so I'll make sure to have different links in the chat so that it will be helpful for all of you joining this event. And that's all from my side. I'm heading it to Jossie, who is our today's speaker. She works with VMware as a software engineer, and she's here today with us to share her knowledge with us about data structures and algorithms. Over to you, Jossie.
Hi, everyone. Thank you so much for having me. Just a little bit more about me, like Maitreyi, I'm sorry if I'm mispronouncing that. What she said, I work at VMware. Before that, I had taken about a 6-year break to raise my kids, and I decided it was time. Before that, I worked at IBM for about, let's see, let me share my screen really quick, for about 9 years. But it was kind of tough to get back into the workforce after six and a half years. So what I'm hoping to accomplish here is kind of show you, I understand a lot of you are either entry level or coming back into the workforce. So with this, I'm hoping that I can kind of help you get started, and also maybe get the ball rolling if you don't know what, some of the topics that you should look at and just consider as you're trying to advance in your career. So what we'll go through today is just talk a little bit about what is data structure and why it's important, different types of data structures that we should how we should understand them, their characteristics, operations that we have available, some of the most popular operations, some of them, and then also talk about specifically 5 different data structures that seem to be the most popular. And then I have a little something extra, and we'll open it up for questions. Okay, so for data structures and algorithms, these are 2 of the most important topics in computer science. So data structure is how you store and organize the data, and algorithms is how you process that data to solve a problem. So together they create programs. And an important fact here is that this is not tied to any specific programming language. Data structures can be used in a variety of different languages. I will show you examples in Java because that's my comfort language, but you can use this in Ruby, C, C++, anything like that. Why it's important. Now, one thing that I've seen is that knowing about data structures is basically what differentiates you from an entry-level engineer to a more seasoned engineer. So the reason is that as programs grow and get a lot more complex, you will see problems with speed and space. And so data structure then gives you a way to store this data more efficiently, and also making it more usable and abstract, which follows some of the solid principles that are important in our field. And I'll talk a little bit about that at the end as well. But the main concept is that you'll have faster programs that are more efficient, and that's always good. Okay, so our type of data structure, this is a diagram I borrowed from the internet because it's so simple and it clearly shows you the breakdown. So first you have these primitive and non-primitive types. Your primitive types are like your single values, and those are your floats, ints, doubles. Your non-primitive is just basically everything else. So from the non-primitive side, you have linear and non-linear. And your linear ones, that just means that data is linked to one another in a sequential manner. So basically each element is linked to the items before and after. Now that is actually more of a doubly linked list in Java, and we can talk about that later. Now, the common ones that we'll be talking about are the ones listed here, which are array, linked list, stack, queue. There's also a hash table that I want to talk about. In nonlinear, you're talking about graphs and trees. And so the point of these is that there are different paths for an element. So each element can get to, yeah.
Sorry, can you please expand your screen?
Oh, yeah.
The slideshow mode.
Let's see. I don't know how to do that. Let me. Does anybody know how to do that? Sorry, I didn't.
Yes, it's the same slideshow option.
Oh, play start right here?
Yes.
Okay, hold on 1 second. That is not allowing me to do what I needed to do. So if I make this bigger.
Yes, you can maximize it. Is it better for everybody? Is it visible? Please put us in the chat. Is the screen visible in a better way for everybody?
Hey, are we getting yeses?
Yes, it seems good now.
Okay. Okay, I just like to have the slides here so I can navigate through them a little bit better. But if that becomes a problem, we'll look at that. Okay, thank you for that. So the where were we? The non-linear, right? So we're talking about trees and graphs, and that just means an element has multiple ways of getting to another element. It's not a sequential sort of path. Now, there are two other concepts in linear where you have static and dynamic. Static means that the size is defined at the time of creation. So this is an array, basically. You cannot change it during runtime. And dynamic means the data structure can change, which is very useful when you don't always have the data at hand, like at the beginning. So the data can grow or shrink, and it can be updated during runtime. All right. All right, so this is the main characteristics, some of the main characteristics of data structures. So correctness, which seems pretty obvious, is just that its interface has to be done correctly, right? So for example, this might make sense like in Java, we assume that the data structures we're given, the arrays and linked list and hash tables, we just take it for granted that their interfaces are done properly and we use them. We don't have to really worry about that. It's been tested, used, and it's been there forever. Now, this is actually more important if you plan to implement a data structure. Like if you're creating one yourself from scratch, then you want to kind of pay attention to that, and that becomes a really important part of it, right? Because other people using it will expect the correctness of this. So the next characteristic is time complexity. This is the total number of operations the algorithm performs to complete the task. It's not the total time an algorithm takes to execute. And the reason it's not that is because there are very many things that can affect that, like the compiler or the processor speed. So for this one, think of big O. The next one is space complexity. This is the total memory required for the algorithm. And this includes the input variables. And this value is also, it also depends on things like the programming language and the compiler used, right? So we'll go to the next one. This is just the possible operations that you might want in the different structures. And these are self-explanatory, so I won't go through that. But I'll give you like a real life example. So let's say there's a line at a store and you're waiting in line. The cashier has to tend to the first person in line. You are given this as a problem, by the way. And somewhere in the line, someone forgot something and they have to leave the line. So you have to remove that person from the line. And then they return, but now they go to the last place in line. And so you have to add them at the end. So now say a cashier closed up and now two lines need to merge, right? So think of this like an online store and how you would implement that now. And then you can see how these functions, these operations would be useful in those scenarios. Okay, so these are the 5 data structures that I want to talk about today: arrays, stack, queue, linked list, and hash tables. A linked list, you'll see it's basically a special type of queue. So we'll talk about that, at least in Java it is. Okay, so the first thing for arrays, these are static and they're all of the same data type. And static, like I said earlier, that just means once you create it, you need to know the size. You cannot resize it. They are the same data types, meaning you can't have ints and floats. If you have ints, it's all ints. If you have floats, it's all floats. They also always start at 0. Okay, on the left side here, you can see it's a one-dimensional array. And here we have multi-dimensional array. So for the one-dimensional, you can see we start at 0. And the last element of the array is always size minus 1. So your elements, you say you have 5 elements in an array. The last element is going to be at spot 4, right? So that's something to look out for because you'll get index out of bounds exception otherwise if you go all the way to 4. The multi-dimensional have 2 indices, and if this is with 2 different dimensions, you can have 3, which you have 3 indices. And the first one points to the row, and the second one for the column. So say you want row 2, column 3. So you'll go.
Jossie,
Yep.
I'm sorry, can you please try to restart your presentation?
Oh, resize it again?
No, restart the presentation, I mean. The slides.
Oh, what happened? Did they like shut it down
Can
and
you
bring it
please
back up?
stop? Yes. Yes, please.
Can you see it?
Is this slide visible for everybody now? Oh, great. Yes, Jossie, you can continue.
Okay.
It's visible now for everybody. Thank you.
Awesome. Awesome. Okay, so let's say we want to go to row 2, column 3. So you go to row 2, column 3, and the element is, I'm sorry, we don't have a column 3 here. Let's just do 2, 2. The element is 9. Okay. All right, and they're both 3 columns, 3 rows, but still you start the index on both of these at 0. All right, so one other cool thing that I wanted to kind of just talk about, because GitHub just released this, is called Code Spaces. Code Spaces is this really cool tool. This is it, and you can just go GitHub Code Spaces, or you can search online for them. They have documentation on how to use this, but this is really cool because say you want to try out a new framework, you want to try Ruby, or you want to try Python, but you don't know what all needs to be installed on your computer. You don't know how to install it, or you don't want to do it because it's just a throwaway program that you're taking a class and you want to just try out their stuff, but you don't want to have all that on your computer and then have to clean it up, right? Because normally when you install that, you don't clean up. You can go to Code Spaces and create an account on GitHub, go to Code Spaces, and they have these templates here. And then you can go to all the templates that they have and look at, what would benefit or fulfill like your case. Or you can go to here and use a blank one and then ask for Java, which is what I did. You can also just create a new one. Anyway, so this is really cool because nothing's running locally on my system, which is great because I can go to my other computer and just pull this up. I can even do it on my phone. Okay, so that's just a little plug on Code Spaces because I found it really incredible. All right, so for an array, say the task, when you're given a problem, you're not normally told, you have an array and do these things. You are actually told you have a list of items that are int and you want to sort them in ascending order. If you know how many items you have ahead of time, you might want to start with an array. So right here in this line, number 11, this is one way to instantiate and also set the values for this array. These here, this is another way you can do it. I hope you guys can see this. I'm not sure how to increase the font here. Let's see. And this is actually running VS Code on the browser, which is the cool thing about this. Like I said, I'm not familiar with how to make this bigger, but I hope you can see this.
Maximize it. You can maximize it. The screen.
Is that helpful? Okay, so
yes.
All right, awesome. So, okay, so this is another way that you can instantiate an array, or you can do it this way, each item, like this. you can just instantiate the array, tell it how many items in the array will be, and then below it, instantiate each item, or this could be in a for loop or something like that. This, I just wanted to show you that by doing this, you're still, even if you don't do them in order, like here 0, 1, 2, 3 on the indices, they still, they're not in order, but they're still the same values as this one. They're just out of order. But you probably want to keep them in order just because it's nicer to read and easier to find as opposed to this. Okay, so all we're told is you have 4 int items always, and you want to sort them, right? So all we're going to do in Java is we're going to print the array, and this arrays.toString is a function that it's like a utility function for the arrays class, where it prints this this array for you. Then we're going to sort them with the same utility class .sort array items. Excuse me. And then we're going to print the items of the array again so we can see how it sorted it. I have already done this on my screen at the bottom, so you can see that they're not sorted in the beginning, and then they're sorted on the second time around. All right, so let's go back to this. The next one that I want to talk about, it's a stack. Now the stack, think of it as a stack of plates or a stack of paper. So these are ordered items. You are allowed nulls and duplicates, but when you think of it, of how you add things to the stack, you add to the top or the back of the stack, and you pop from the back of the stack as well. Okay, so insertion and deletion is only allowed at one end. It's called the top. LIFO is last in, first out, or FILO, same thing, first in, last out. Different operations that you're allowed here. Some of them are push, you add to the top, and pop. You got to be careful with pop, because pop is not only going to get you that object, or that item, it actually pops it from the stack and removes it. So if you just want to look at what the last item was, you have to do a peek on there. Okay, so now let's look at what that stack looks like. So again, they're not going to be specific with here's a stack, but they'll probably say, give a list of items and reverse it. And that's the thing that I kind of forgot to mention, is that stack helps you with things like recursion, and it's used for like undo in a text editor. Also, they're very important in compilers for like memory stack. You've heard of that, I'm sure. Or think of stack trace in Java when you're trying to debug and see what were the most recent operations performed. That's what they're using. Okay, so say they give you a list of items and now they want to reverse it. So they give you a word and you create a stack. In Java, it's just the stack class, and you start pushing items into your stack. Now we're gonna print here what we're gonna go through the entire stack and print each item. Then what we're gonna do is do a while loop, and while it's not empty, we're gonna start popping the items. Remember, this is gonna pop it, which means it's gonna give it to you and remove it. So we're just removing it. If you had to keep the item or something, then you might want to put that in a different data structure. Okay, so let's see what this one looks like. So the original stack was called stack, and reverse is called kcat. So that's what that looks like. Let me see. Okay. Oh, toggle size, content. Okay. I hope that one you guys can see too. Okay, the next one, we have a queue. Now, a queue you can think of in a line at the grocery store like we talked about earlier. This one's first in, first out. So the operations are on queue, DQ is full, is empty, peak gets the last element. So this one's a little different than the stack because when you DQ from the front, not from the back. Okay, you add to the back and you DQ from the front, just like I said, a line at the grocery store. So things that you can think of this one are like for accessing files, like two people trying to get the same file, but you have a line. So first come, first serve kind of thing. Also like a print queue, right? You have to wait in line to print your stuff. Another one that you might be familiar with is an email in your inbox. It's usually always in a queue format displayed. Okay, so let's go see just a very quick example of a queue. Okay, so you are giving the list, and all we want to do is print the names of the people waiting in line in order which was added. So in Java, queue is actually an interface, and you cannot instantiate interfaces. You have to instantiate one of its implementing class. And queue has quite a bit of implementing class, like priority queue and a bunch of others. I'm using the linked list, which is actually the next structure, that the data structure that we were going to talk about. So a linked list is basically just a queue. And there are other types of queues, like I said. You might be asking why a linked list and not an array? Well, this is a line that you don't know who else is coming. So you'll be adding to that line, which you can't, adding elements to the line or removing elements, which you can't do. You can null them out in an array, but the size would still always be the same. Okay, so let's create this queue in form of a linked list and let's start adding names. Julie, Mark, Kate. We're going to print the original list, and then we're going to add two more names, Tom, Kathy, and print the new one and see what that looks like. All right, so we have Julie, Mark, Kate, and then the new one, Julie, Mark, Kate, Tom, Kathy. All right. Let's go back to our chart here. Basically, this is the linked list that we just talked about. A few more things about this is that you can think of it as a playlist. You can access previous and next in a doubly linked list. Each element is referred to as a node and contains data known as element. And so it has a reference or link to the next element in the list. You can add or remove elements like we talked about. You cannot do that in an array. There is no random access, so you do have to go from one to the next to the next. The first element is the head, and it points to the next element. Now, the last element is called the tail, and it points to null, indicating it's the end of the list. So there are no more items in this. Okay. I showed you that already in code, so we won't go through that one again. Now, excuse me, hash table, it is often referred as a dictionary. It has key value pairs, and it is one of my favorites to use because of how easy it is to use and has direct access to its items, so it's fast. It's more efficient than like search trees. And an array, so basically how this is implemented, it's an array that is addressed with a hash function. So there's this hashing thing that happens. And so the hash function is to compute an index for that array that's done in the back. And it's also called a hash code. So during lookup, when the key is hashed, and the resulting hash indicates where the corresponding value is stored. So like right here is the hash function that happens. And then these are the hashes, and we go back to how to access those in the array. You can see how that's very quickly, because it's just an operation that's done. We don't actually store the key, but a hash to that key. All right, so let's take a look at how that one is done really quick. All right, so you are giving a list of names with their student ID, and you just want to store them and display. So you create a hash table in Java. These are the key and value. This is called generic, so you can define what type your key and your data will be. In this case, I selected integer for the student ID and string for their name. And then the next 3 lines, we put we just start adding the items. All right, then here, the slide, we're printing the hash table to see what the values are. One thing to note is that you cannot add nulls or to the key or value. You will get a null pointer exception, so you have to have a value to it. All right, so then after printing, I just added a new one so you can see that this can be resized, and then I print that out again. All right, so let's do that really quick. Okay, so at the bottom there, you can see the original was Steve and Jay. Okay, so this is something that I wanted to show you. The reason line 12 and 13, there's only 2 items is because the ID cannot be a duplicate. So it only picks up the last item that you added with that ID. So we lose Lori in here. Okay, so be sure that your IDs are unique, or it might be that you want to override this ID with someone else, and that's totally fine, right? And then on the second one, you still see Jay and Steve and Karen this time. All right. Okay, so that's it for that. One thing that I wanted to talk to you about, this is like the extra thing that I wanted to bring up to you, because I know a lot of you are entry-level returners, and I just wanted to talk a little bit about how to solve any problem. And this is very applicable to interviews, like those difficult, tech interviews that everybody kind of dreads, and whiteboard interviews. But you can also use this when someone's presenting you a problem at work and you want to solve a problem. This is really good to make sure that like you're driving the problem forward to a solution and everybody understands it. So this, there's a like 15-minute video on this, and I put the link in the last slide here so you can get to that if you want to look at it. But so full stack came up with this concept, this framework called reacto. And the first step, it's when you're given a question, you repeat the question. That allows you 2 things. Your brain is quickly trying to solve that problem behind the scenes. And so that buys you a little bit of time to try to solve that problem. What it also does is you're repeating the question and you're making sure that you understand what they're asking you. So you want to make sure that you're on the same page and you're not misunderstanding what they're asking of you. And he goes in the clip, he goes into each of these a little bit deeper. So number 2 is provide examples. Don't write any code at all. Just provide examples of the inputs and outputs of what you are expecting. This also, again, gives you more of like, okay, this is what we're solving. You're trying to solve the code and trying to understand the question and make sure you're on the same page. Okay, the third thing you want to do is describe the approach. So describe what you're about to do. This is so important. A lot of people tend to skip this, is what they're saying, because you just want to write the code, but don't really try to not get to that point. Because what happens when you're describing the approach, especially in an interview, it becomes collaborative. You're kind of telling them what you're about to do, and it really replicates a real scenario when you're with your teammates and you're describing what you're about to do, and so the other person feels like they're kind of compelled to collaborate in that approach, and it gives them sort of like okay, maybe don't go this path, and they kind of try to help you out, or try to say, you can get feedback from that and say, oh, that's a good idea, or I wouldn't do it that way, I would do this. So it kind of leads you to the right direction. The fourth thing is code. But what they say is try to start your code at a very high level. If it needs interfaces or anything like that, try to start really high level. Because once you start coding on the nitty gritty, you kind of lose sight of the big problem that you're trying to solve. If you just write all the functions that you need with inputs and outputs, there might be a function there that they say, hey, you know what? Don't worry about implementing that one. That's pretty self-explanatory by the name you chose. So let's just leave it out. Also, you don't have to like do naming. If you don't implement the functions, like we get really stuck on naming variables and things like that. So then you avoid all that and have time to really just design the problem and focus on the bigger ticket items, right? Number 5, they suggest that you test. So once you think you have your code written well, choose a set of parameters and go through it. Basically do number 2 with the code. Walk through the code and show how it's actually working. Or if you have time, write a test file, write a test. But at least if there's no time for that, if it's one of those shorter, like 30, 40 minute, and you don't have time to write a test, just like go through it manually. Number 6 is important because it helps you kind of think of what's next. How would you optimize this thing that you did? Because you're usually in crunch time, and we always have to refactor our code. What would you do next? What would you do next time? Or what would you do better? Describe what you do better, and then think of big O. Maybe you don't need recursion. Maybe you don't, and you can use a stack, right? Something like that. So these are 6 steps that they recommend to perform when you're like, solving a problem, any problem, or really an interview question. All right, so that was my presentation. So if we have any questions, we can go through those. I guess there were questions that I missed. Let's see. So there's a question about how to.
Yes, we have a question about hash tables if they are unordered.
Yeah, so hash tables are not ordered. That's the thing. Yes, they're not ordered. If you want an ordered hash table, there is one that you can use, and I don't have it off the top of my head exactly which one that is, but go to the Java documentation and take a look and see.
Great. So we have another question also, which is about recommendation. There's an attendee who says he's into IBM Python DS online program, and is there any recommendation which you can share with the audiences about landing a job in an entry data analyst role at companies like IBM?
I mean, I think that question applies for any company. I think at the end of the year, just keep in mind that at the end of the year, a lot of companies freeze hiring. So it's really hard to get a job at the end of the year. It's not you, it's me kind of thing. So really, truly don't take that to heart. It's not your fault. It's nothing that you're doing. It's just companies don't tend to hire for many reasons, holidays, budgets, and then they'll reassess at the beginning of the year. So that's one thing. The other thing, I think if you follow that Reacto process and take a look, here's the resources. I'll send these out so we can send them out to those who want it. This, I believe this is the one right here. Take a look at that and then practice. But when people say practice, HackerRank or practice, those are good to practice, but that's only one step of the Reacto process. You want to practice, like really going through that process, that Reacto process, because it's so hard to ask questions and then to get asked a question, not jump into code. And that's what the Reacto framework is saying. Don't jump into code. That's step number 4. So you have to practice not jumping into code. You have to practice repeating the question, drawing up examples and describing your approach, then code. So that would be my thing, is practice doing this framework with the problems that you're finding online. And then just, keep practicing this over and over. If you don't get it the first time, then practice it until you're comfortable with this process.
That's great to know. Thank you for sharing, Jossie. Next question we have is, are there any 5 or 6 main data items that we need to know about?
Yeah, I think the ones that we covered, I think, and I have another chart here, what's next for you. I would say deep dive in data structures. Like, this is a very high level lecture on data structures. So go back to arrays, spend a week on them, on all the functions, whatever programming language you use. If you use Java, spend like a week, maybe that's too long. Like, I'm just saying like 5 to 6 hours on arrays, and just know it really well, know all the utility functions that is provided, then go to stack and do the same, then go to hash table and do the same, then read maybe other problems and try to think of which data structure would fit the best, because that is how you would be given the problem. You're not usually like, here's a stack and do this for me. You're given usually a high level problem that you then have to figure out which data structure fits. So try to practice that. This is the other thing that I would say. Solid principles are really important. How to be a better programmer, and there's a link in here that I put. If I don't have it here, I'll put it here. I don't think it's in here, but I'm going to add it. There's a 45-minute talk from Sandy Metz, and I love watching that video. It's kind of old now, but it's still very applicable, because solid is one of those fundamental things that don't change. And so the more you watch and listen and read about it, the better you'll get at it. You have to think of dry, don't repeat yourself. Design patterns, there's a few books they're highly recommended. There's other books for data structures, and I can add those in the resources as well. For Java, I would recommend really familiarize yourself with generics, optionals, and stream. And the reason for optionals and stream is when you look at the code that I've written, I have some for loops in here and then in the array. And I didn't want to not do that for this class, but you really don't ever have to write a for loop when you're doing a stream. You can just read about it and you'll see how this can turn into a one-line function, one line of code. So that would be my recommendation for what's next. I think you're on mute. I'm sorry. I'm sorry.
So the best way to approach learning algorithms, if there are multiple algorithms, would there be any recommendation from your side that you can share with us, Jossie?
To think about algorithms and how to solve that, there is like I said, there's a couple books that are called Data Structures and Algorithms. I think the best thing is to read books like that. and then try to solve them, and try to solve them in that reactive framework. So put those together, what you learned from here, make sure that you continue to dive deep in each of these data structures, and then find problems online and see about how you would solve them. And some of the problems will have solutions, and they might be solved in a stack. Well, tell yourself, can I do this in a queue? Maybe I'll start with a queue and see how it would look and why they chose a stack as opposed to a queue. And solve the same problem with an array or a hash table, and solve them so that you can start learning what the benefits and drawbacks of each of the data structures are. And that way you'll get better at understanding which data structure you want to use for what problem. You won't even have to think about it.
That's good to know. Thank you. And the next question we have is there a code test necessary for completing in any kind of event interviews?
Test, I mean, I guess it depends on the interviews. Like, my favorite interviews are the ones that are like take home, because that gives you like a take home project, because that gives you an opportunity to work on it like you would a real project, right? You would take it, and then if you are given the opportunity to write a take home, always include tests, always. And we usually use JUnit. It has incredible support and easy to use, and bootstrap it. So that would be my recommendation for that. If you're not given the time to do that, you can test it manually, like we talked about, with inputs and outputs.
So if there are any more questions, please let us know. We still have more time.
So I see a question there about teaching other data structure classes. I don't consider myself an expert in data structures, but one thing is for sure, when you can teach a subject, you become an expert. So it might be something that I think about in the future. And I encourage you to take this, learn, and also teach it to other people, because that's when you know you really learned it.
Did I understand? So it's always good to teach while learning. Makes sense. So are there any other questions which anybody has for today? Was today's session helpful for everybody? Please let us know in the chat before we wrap up today's event. Awesome. Thanks for letting us know about your feedbacks. Thank you so much for joining everybody and making our event successful today. Also, thank you, Jossie, for sharing your views about data structures and algorithms today with all of us. And we hope that everybody has an amazing day, and in advance, happy Thanksgiving Day for the ones who are enjoying it, who are going to celebrate it. And we really hope that everybody has a good time. Thank you and take care. Thank you.